A rowboat is crossing a river that is 500 meters wide and traveling due east at a speed of 2.2 meters per second. The river's current is zero point 0.8 meters per second due south. So I drew a couple of vectors here just to describe my change in x and my change in y. So the travel east is 2.2 meters per second. The travel south is zero point 0.8 meters per second. So the first question says, what is the resultant velocity of the boat? So what we're really saying is to get the resultant, what's happening when both of these things are interacting on the boat at the same time? So we've got the square root of a squared plus b squared. So v, in this case, I used a capital V for velocity, is the square root of 2.2 squared plus 8 squared, all under the radical. When I put that in a calculator, my result for the resultant is 2.34 meters per second. That's the velocity of the boat with these two forces acting on it. So we've got 2.34 meters per second. That's the answer to question A. Now in question B, how long does it take for the boat to cross the river? We already know that the river is 500 meters wide. So 500 meters wide. So we want to be careful here. We're talking about just the change in x. Getting across the river, we need to travel 500 feet across the river. So our distance due east, we're not traveling east at 2.34 meters per second. We're only traveling east the 2.2 meters per second, because that's our distance traveled east. So we have to travel east an entire 500 meters to get across the river. So what we're really going to do is set up our equation x of t equals 2.2t. But our x of t in this case is 500 because we need to travel 500 meters. So when we substitute in 500 for our x of t, now we want to find out what t is. So we're going to divide by 2.2. And that's how we get 500 meters divided by 2.2 meters gives us our time in seconds. When we do that calculation, 500 divided by 2.2, we get 227.27. So after 227.27 seconds, the rowboat has reached the other side of the water. Now, question B talked about our vertical distance, our travel east. Question C talks about our travel south. So how far downstream is the boat when it reaches the other side? So this time I'm going to use y of t. And our travel south is 8.8 meters per second. So y of t equals 0.8 t. In this case, we don't know our distance, we know our time. So we're going to substitute in for t 227.27. So 0.8 times 227.27 gives us our distance y of t is 181.816 meters. And that's just a quick glance at how we can actually use vectors for things that are occurring in the real world. That's question number